Leonida, what is this?
Hey, everybody, and welcome to Show and Tell. It's time to check in with makers and crafters and hackers and sewers and people from around the world who want to come by and show and share their projects. What's called Show and Tell. So we're going to have some people from Adafruit. We're going to have some people from DigiKey.
That's right.
We're going to have some people from the community. It's going to be a fun, full hour.
We've been doing this for about a decade. Show and Tell. People around the world show and share their projects every single week as part of our Adafruit live series of shows. We have Ask an Engineer, we have Show and Tell, we have 3D printing, we have John Park's workshop, we have Scott's program, deep dive in CircuitPython and more.
Yeah.
And all of our other content that we do every single week.
Yeah.
But thank you for joining us. We've moved the format from half an hour to a full hour. We're going to stick with this, mostly because there's so many people showing and sharing their projects each week. And thank you for being part of this journey with us, everyone. First up, Sean. Hey, Sean, how's it going this week?
Good. How are you guys doing?
Good.
Hanging in there.
We are here. We are doing this.
Sweet deal. Yeah. So, yeah, thanks for having me on. And I'm excited to show updates to my project. I think I was on last month showing off my anomaly detection system. So I'm going to share my screen, get everybody caught up to what I've been working on.
Yeah.
You had that cool fan thing and machine learning and doing a bunch of stuff.
Yeah, exactly. All right. So.
All right.
Am I sharing screen? Are we good?
Yes.
Screen is shared.
Good deal. So this is what I've got sitting up on my fan right now, and it's an ESP32 Feather Huzzah 32, and kind of like what I had last time, right? I've got the accelerometer, the MSA 301, that's just grabbing data. It's just grabbing about 200 samples per data in the X, Y, and Z axes, and then that's just being fed to that ESP32. Now the difference this time is last time I was piping that data over Wi-Fi from the ESP32 to my computer, where my computer was doing all the machine learning to determine if there was an anomaly on my fan or not. I've moved that model over to the ESP32, so the machine learning is all being done locally. There is no Wi-Fi connection anymore. And so here's the setup. I've got it up on a fan, something like this. And I've trained a model, this machine learning model, to look for anomalies. And this is kind of what your XYZ axes look like in a raw format. And I'm using something called an autoencoder, which I won't get into here. It's just some fancy math.
Why not?
All right. So if you tune into my channel, I've got like, hour-long presentations on how autoencoders work now.
Yeah.
They're really cool. The idea is I can train this model on my laptop to look for anomalies. And then it's basically a file. It's just a C byte array that I copy over to my ESP32. I load that onto the fan, and then I just let it run. And so this is kind of what it looks like right now. I took a picture of this earlier. It's just taped to my fan. I collected data.
That's fine.
Fine.
Sweet. And it's running this machine learning algorithm, and there's no Wi-Fi. So I'm going to go ahead and see if I can give the demo now. So I'm going to stop sharing the screen. I'm going to give the live demo, and we all pray that everything works on demo day, right?
Well, we do this show every.
You learn a lot if you don't.
We do this show every week, and so I kind of feel like if it doesn't work out, then you have something to do next week.
That's true. It's all a learning process, right?
Right.
So it's running, and it thinks it's in normal operation. I'm going to go ahead and touch this. Can you hear that buzzing?
Yeah.
So that's letting me know that an anomaly has occurred. And similarly, I can actually break the chain on my fan. That's perfect. If it goes to a different mode, like the fan's on high right now, and if I turn it off.
That's an anomaly.
That's an anomaly.
Yeah.
There's all sorts of anomalies happening.
It's also a broken chain detector. It does all sorts of things.
That's awesome.
Perfect. And my dog does not like that beeping noise.
No one likes it.
Your dog is an anomaly detector.
At all. Okay. Is it stopped or is it okay? I'm gonna have to actually kill this because that noise is.
Well, that's why you taped it on, right? So it's easy to remove.
Yeah, exactly. So I've had a few people. So Lamore, last time you said this would be good in something like a compressor, which is a great idea. And I had somebody reach out to me saying like, hey, I'm interested in experimenting with this thing on something like a plane engine. I can't remember if it was a turbine or a basic prop, but trying to determine if there's something wrong with it in flight, which would be really cool. So potential uses for something like this anomaly detection on a motor or a bearing. I hopefully it inspires some people to look into more applications.
I totally agree, because it's like often, with bearings and motors and compressors and other mechanical things, it's like they're really good until just like you get like 1 day warning and then they die. Like you often don't get a lot of warning, but you do get some. Like there is some slight change in performance right before it fails, but people, especially if they're not used to it or they don't know what they're looking for, they're like, oh, whatever, the compressor's just acting up today, and then it's like the next day it's gone. They don't realize like that was your warning.
Yeah, and a lot of times that's, you as a human, your capability to hear it, see it, feel it as to what's going on. And the idea is, can we train machines to look for that?
Yeah. Especially what's built into, the compressors are a couple $1,000s. If it's $10 to add, fuzzy logic failure detection, that'd be great.
Yeah, exactly.
John.
Thank you.
All right. If people want to find out more about this project and some of the stuff you're up to, what's the best place?
So most of this stuff is going onto digikey.com/en/maker. That's their maker.io site. And it's also on YouTube for at youtube.com/user/digikey. I'm going to be posting all of this code on those as well. I'll make sure to go into the Discord. And I believe there's another live stream that I can post links to the tutorials and code for all of this.
Oh, good. Can you hear me that down there? I do have one thing, just speaking of DigiKey. So they were super nice. They said, you look like you could use a care pack. I don't know if I look tired online or something like that. So they have these work from home care packs. And I think they sent these to their teams that were working from home. But I collect some, you could probably tell my hobbies are revolving around electronic companies. So it comes with all sorts of things. This is a really cool mouse pad. Look at this. This is like so cyber. You get a mouse pad. They have DigiKey playing cards. So I do have a small collection of electronic company playing cards. So I'm adding it to that. And then they have some headphones, and then they have this like insulated cup. So I wanted to thank DigiKey for sending this out to us, because we work at the factory, but we also work at home too. And they also have some hand sanitizer.
Perfect.
So anyway, special shout out and thanks to DigiKey for sending that along. And this reminds you, those old graphic card boxes that have like the amazing graphics on the side, and you would buy the graphics card because of that.
And the box is like this big, and the card was like this small.
It reminds me of that. It's really cool, and I like this. It's like, hey, we're friends. So okay.
Okay, we're friends.
All right. Well, thank you so much, Sean. And thank you.
Yeah, thank you.
Okay, right on. Let's go to Aaron. Hello, Aaron. How are you?
Good. How are you?
Good.
Let's see. I just wanted to come and show off my new mask. Masks look like they're kind of here to stay. This one, I just did a new tutorial that I just launched this week, and it has a window. The window has anti-fog in it, so you can talk and sing little songs and do all your things, and it won't fog up, which is pretty cool. And the whole thing is made with no sewing. I just used glue, and then I actually stapled it on the sides.
Yeah, this is something
which
that
is
we
pretty cool. It's really easy to make.
We had people contact us and say, hey, I'm hard of hearing, or somebody I know lip reads, but these masks make it harder to emote. So I thought like this would be a cool thing to show off. You're like such a good crafty person. I was like, I know you'll come up with a design.
It's much easier to communicate in, that's for sure. Like just even if you aren't hard of hearing, like a lot of people are just visual people, and you want to see people's faces when they talk. You want to know if they're smiling, anything like that.
Yeah.
So it's pretty helpful for that. And I did it with no sewing. My husband watched the video, and he's like, this is so easy. Even a man could make it, which I thought was hilarious.
That's true. That's what we were going to use as the aid for tagline, but we decided to.
Yeah, the original thing was going to be electronics so easy, a girl could do it. And at the time, that would have been okay. It would have been like kind of in your face, like, oh my God. But now, all the engineers I know are women, so it wouldn't have, that tagline wouldn't have made sense. One thing that about this project, and kind of what you're saying, is a lot of folks, they want to be able to see if someone's smiling, get more, physical cues.
Yeah.
I heard that jury selection is going to be a little tougher, because the people who select juries, they look at the people if they're smiling, body language, all sorts of things. So I think like what Aaron said, I think masks are here to stay. I think a lot of us are probably like, yeah, masks are going to be here for a bit. So this is just yet another thing to explore with this real estate that we have that we're kind of, modifying and changing. New York is very fashionable, and it's now summertime. We're seeing an entire menagerie of masks being made. There's ones, I saw one today. It was like a hula skirt on top of a mask. It was awesome.
That's
So
awesome.
anyways, thank you so much, Aaron. We'll be playing that video tonight during Ask an Engineer as well.
All right. Thanks, Aaron. Okay, next up, JP.
All right, JP has a mustache mask.
Yes, I do. And
all right, how's it going?
it's going well, thank you. I've got a couple things to show. So I had done for the past couple of weeks, I've shown off this really large scale protest sign, which uses one of our LED matrix displays, and I'm displaying graphics on there. And this is using our CircuitPython library to use a display IO and talk to these RGB matrix displays. I also had a smaller one, and I wanted to start just going through and learning how we're talking to these things using text, using scrolling, using other methods. And so I'm doing like kind of almost the hello world of this, which is just I'm kind of blinking between two different lines of text. And I may eventually turn this into a more elaborate on-air project, but I feel like on-air is something a lot more people could use now because they're in conference calls and Zoom chats and things like that. Yeah. People might want to have a way to throw something like that on their door. And the board I'm running this one on is actually our Airlift Metro M4. So this has Wi-Fi on it. So there's the potential to have it as sort of an IoT display. And that could even just be as simple as being able to send it the command of whether you're on air or not, or it could be doing something more sophisticated than that to determine if you're on air, like on a YouTube channel that's gone live, that kind of thing. And we've done projects like that before, but I thought it would be cool to try one myself and maybe update for the CircuitPython version of these, because we've done them in Arduino before. So that's just a kind of a teaser of something I'm working on a little bit. And if I can, I have one other thing I wanted to show.
Yeah.
I got a PCB in the mail from Cedar Grove Studios, and this is for a new clock. So I had made this little Metro-based clock a long time ago, and it's the shop clock in my workshop. Cedar Grove updated that to run on CircuitPython with a real-time clock and a feather, and it's going to use one of these big honkin' displays. So I'll be putting that together eventually, and I'll have a nicer, newer, better clock, I think, because the current one I have to actually open up the sketch in Arduino to update my daylight savings time twice a year. So this one does that automatically. It's more sophisticated and has some nice strong. Yeah, so that'll be fun.
Okay.
All right.
And note, I'll be out. There will be no John Parks workshop tomorrow. I'll be out for a couple of days of sort of vacation and kayaking.
That's right.
Okay.
And then next week, shows on Tuesday, it's Make Code, and then back to your shows on Thursday. And then one programming update, the Make Code show is going to be on Twitch going forward. Mixer is going to be part of Facebook Gaming. So our friends at Microsoft said broadcast the Make Code show on Tuesdays. So you'll see that. We'll get the word out and everything, but that's one of the upcoming.
That's a fact. Yep, definitely.
All right. Thank you so much, JP.
Okay, thank you.
All right, next
up
is Scott. What you got going on?
Hello. I've got two things. First, as folks know, I've been working on the ESP32S2, and I was working on SPI and was having a lot of trouble, but I managed to get SPI working, which is exciting. So what you can see here is just the REPL output actually on the display there. And that's so that's coming from the Sala here with my Featherwing adapter, and the camera is definitely not super happy, but you can see that it works, which is exciting.
It's so cool that you just got like SPI working, and then it's like, okay, now every display we have works too.
Yeah. I mean, I think it's a testament to how we like organized everything so that it's kind of nicely organized and things just work once the foundations work.
Yeah.
So I had a little bit to do in making sure that like the displays could work without PWM working, but I'll check that in, and that'll make it just a bit even easier. And this is using DMA as well. So I clocked it up to 40 megahertz on the SPI bus, so it should be pretty snappy. And then along with that, I actually deleted or removed the delay that was slowing us down, so it should be running faster. And at the same time, I boosted the CPU from 160 megahertz to 240 megahertz. And so if people want to try that out, it's on my current branch. You can ping me on Discord, and I can help you get it going. but hoping to get a PR out either tomorrow or on Friday. So
Awesome.
check out my deep dive for that.
Right.
Good
And then you
stuff.
got another project. I'm going to add the screen here.
Yeah. So the other thing I've been working on in my like evenings now is this is election calendar, electioncal.us. I talked about it, I think, a couple weeks ago, but I've been working on it. And I now have this idea of reminders. So this is the landing page and the next kind of reminder that we have across the whole US, which is not correct because I haven't put all the data in, but for the data I have put in. So in Missouri, you have to mail your absentee application so that it's received by July 22nd. And then if you're in a particular state, you can select here, like if you're in New York and the Queens or whatever, now you can see the reminder when you have to mail your application for absentee, and then also all the different dates that are upcoming.
Okay.
And this is because your primary was yesterday. This is all about the next election that we have in here, which is the general election on the November 3rd.
Okay.
Outstanding. Thank you so much. For folks that pay attention to this stuff, there's so much data that's out there, and you can do more stuff with it. And being able to get reminders. We just had our primary here in New York, and I was beta tester. I think Scott tweeted it. I don't know. It feels like it was a couple weeks ago. It was probably like last month because time is moving in
It's weird.
in
And now it's
interesting
like,
ways now.
who knows?
But it was really helpful, and I was able to keep track of everything. But the other thing I wanted to mention is if folks work at companies, especially large companies, that are kind of on the fence about should I give our team off, paid day off for voting? Because I hear about this Patagonia company does it, and this other company does it. Feel free to email me, pt@adafruit.com. Adafruit's been doing this for a while, and we thought it was important. U.S. is a little different than the rest of the world. The rest of the world usually voting is like on a weekend or it's a day off. U.S. we're going to probably eventually have that, but a lot of companies are starting to offer that. But if you need help navigating it with your company, some companies that we've helped out with, you could approach it to sometimes it's like HR, and you say, hey, what would it take? What metric could we hit as an organization? What could we do together to make this as a paid day off? Regardless of what politics people having a day off to vote is something I think we can all agree on.
Or work on the polls. I mean, there needs to be more poll observers. We need people to help with voting.
Yeah.
The process is all volunteer based.
So anyways, if anyone needs a hand, let us know, because we have our handbook. We could cut and paste how we did it. We've talked to employment lawyers before we did it. But you're probably going to see this in the news a lot. There's a lot of companies, especially outdoor clothing companies that are really moving on this type of thing. So anyways, thank you so much, Scott. And if anyone needs help about voting coming up, how to get it into your company, feel free to drop me a note, and I'll share anything I can and hopefully help out.
Yeah, and I should just say that you can get JSON feeds of all this stuff too. So if you want to make a PyPortal project, you can check that out as well. It's linked to from the page.
All right. And Scott, when's your next video show that you're doing?
Friday at 2.
Friday at 2. All right. Thanks.
And that's 2 Pacific because I'm in Pacific time.
Pacific. Okay. All right. Thank you so much.
Thank you.
All right. Next up, we're going to go to Melissa. Hello. Melissa, what you got going on?
I have a sign here that I have been working on. I showed it off last week, but it was still kind of in the middle of the build stage. But over this weekend, I wrote a little library for it, and it makes it really easy to script. Here, I'm going to run a demo.
Oh, wow.
Yay.
So I added animations, shadows, different opacities of the foreground and background.
Oh, great.
Yeah.
And it's all done with Pillow for the graphics work. And so I just have it kind of looping right now with 4 different things, but it's written in Python, so it's really easy to script. And it also uses this black LED acrylic on here. So if I go ahead and shut it off, you can kind of see it just comes off as a matte finish. And so this one's made with the little pixel purses, the little LEDs off of those. And I'm going to be publishing a library soon on that. Just kind of need to polish it off at this point and write some examples and stuff. And the other thing I've been working on is I have been moving the PyPortal library so it can run on a Raspberry Pi here. So let me just flip over to this one. And I have a little Bitcoin example here. It's going to take a second or like 10 seconds to run or something like that.
I don't see anything.
Because it needs to be optimized, really. But
Oh, there you go.
yeah, and it even has a little audio. And it takes a few seconds to show the coin.
You can do it, Blinka.
And there it goes.
Wow,
So-
Bitcoin went up a lot.
Yeah. I think it was like 300 more last night or something like that. So.
All right, cool. All right, lots of good stuff coming from Melissa's desk.
All right. Thank you so much, Melissa.
Thank you.
Thanks.
All right. Next up, we're going to go to Gnome Pedro. Gnome Pedro, what you got going on this week?
Hey, what's
guys.
up, folks? You can't tell, but I am smiling. Yeah, so this week on 3D Hangouts, Phil, you found this really cool material from Felty that they're using to make masks. They released a kit, I think it was like 2 weeks ago. So we thought we'd make some 3D printed parts for it. So first off, these little holders, no sewing for these as well. They just clip into the ends here. You just cut like a 9 by 6.5 rectangle, and you just press those on. And they're pretty nice. They're actually a little bit thinner than the surgical masks with the, what was it, like 95% efficiency on that. And they tout all the rest of the stats on that. But in addition to that, we also wanted to make some magnetic ear savers, because why not add magnets to 3D printed parts? So of course you have the adjusters here. You have these little hooks. You can adjust the size of them. And then we're just using these little magnets that we have in the store to clip those on. Makes it really easy to remove. And then put on. They're pretty tough.
I like
They
that.
need to be
I'm
strong
always like,
for days.
Yeah, I tried a bunch of different sized ones.
all right,
but
looks great.
all
Yeah.
off. But yeah, the ones we have in the store are really strong and definitely suitable for that. Won't come off. And
Yeah, a couple notes about this. We ran into this company because we've been trying to find a USA manufacturer of N95 like material as close to or more, and this is it, and it's in the USA. Great. And we also are still on a search for the best way to manufacture masks in the USA. It's only been 3 months, but it feels like a year, but it's been 3 months since we started on this journey of how would a supply chain work if it was all in the US. So this is just one part of it right now. You can get these materials in the US. They used to do air filtering. Then they pivoted to this material. There's a big community of people making these masks. And then the next stage is we're going to try to feed it into different types of machines that we would be able to service and or use in the US. We all remember what happened with the supply chain that's only exclusively in China when all sorts of things happen in March and April. All of a sudden prices change, availability changed. So we wanted to see what was possible. But this is a good first step where you can make your own stuff with materials available here in the US. So thanks for doing this project.
Yeah, and definitely helps to make something that really works with your face, because I just got a bunch of these ones from Disney and none of them fit. I got like medium-sized ones. They barely fit my little 7-year-old kid. So definitely works to be able to fit them and size them and then try them out before you go out in public with these. So yeah.
I always like no sew, easily reusable.
Yeah.
You can wash these and then just get new filter material and just cut up a piece and then put it together.
Yeah, we talked to a designer in the UK, and she said even though the PPE is mostly used for healthcare professionals that are women, it's well over 50% of the workforce. The PPE was designed for men's faces, so it never quite fit. So she's starting to do a redesign of PPE, and these are the type of things. If it's not going to work for a 7-year-old, it's not going to work for other people as well. So there's lots of challenges because we've had PPE and okay, everybody now use it. It wasn't in everyone's face literally until now. So I think we'll see some innovation. So thanks for working on it.
No, thanks.
Excellent.
And then again, 3D Hangouts did a whole half hour on showing all you have change the size of these, change the diameter and the dimensions for these. So lots of good design tips there if you want to edit these and make your own.
All right, looks great too.
Right on.
Thank you for modeling, Noe.
All right. Thank you
Looking
so much.
good.
I can tell you're smiling. I can
Yeah,
tell.
I can tell.
It's all in the eyes.
I
Yeah.
say it all.
Yeah. All right, thank you, Pedro.
All right. Next up, Paint Your Dragon. Paint Your Dragon. What are you doing this week?
Hello. Great.
On.
Well, last week was Matrix show and tell, and I didn't bring a Matrix project, so I brought it by this week.
You're back.
Instead. I'll switch.
That's okay. You can always follow up.
Yeah. So I already blogged about this, but I thought I would show it and tell it. I've been working on the Protomatter library for these LED matrices, and boy, we support, I don't remember, like 6 different chips now or something, and you have to get the timing right on all these different devices, and that involves hooking up a logic analyzer and seeing what's actually coming off the chip and then adjusting the code to make it do the right thing.
Yeah, it's so timing specific. Like, it's incredibly sensitive.
Right. And having to do this again and again for 6 different chips, and then hooking up not just the matrix, but the logic analyzer, there's all this just super fussy wiring you have to do. And you can see my wires they're falling off now.
No.
It gets really stressful just having this thing on your desk that you breathe wrong and your wires are going to fall off. And so I finally made some adapter boards that it's just a pass through. Here's the input to the matrix, and here's the end that goes to the microcontroller. And this guy sits in the middle, and you take these connectors off the logic analyzer, and you just plug them in. And it saves so much time, and it's a real solid connection. It's not going to fall off. There's actually 2 of these that hook on. And I don't know why I didn't do this sooner, because, a logic analyzer costs like thousands of dollars. And why am I sitting here playing around with jumper wires when I can, the little adapter board, it's just headers. It's a totally passive thing. So I finally got around to do that, made the little adapter boards. It works as a pass-through on the cable, or you can just plug it with a different socket on it.
Yeah.
Plug it straight into
I
the
like
main.
doing that. I like the little back socket trick.
Yeah, so that's one option. Or if you're okay with the data being not in sync with the signals, if you're just trying to get like your clock and latch right, you can hook up on the output side of the matrix. And you don't even need the ribbon cable in that case. You can just hook the logic analyzer up to that. And this is such a huge time saver, and I am just kicking myself for not having done this.
Well, you should celebrate that you've done it now.
Yes, exactly, because I want to go in there and do a big refactor on that code and, fine tune the time. All this stuff I've done, I have to go in there and do it again, basically.
Yeah.
And so I am happy now that I at least have these adapters and I can be hooked up and developing, in seconds instead of stressing out over this garbage again and again. So
I feel like you need to make as seen on TV. It's like, is this you? And it's like there's jumper wires everywhere.
It's exactly, yes.
The Paint Your Dragon stabilizer.
Cleaning supplies.
Order now and get 2 for $19.95.
I glued these together and turned them into a boat.
Yep. So anyway, the little Osh Park PCBs, I got 3 of them. It was like $10 or whatever, and it's like.
All right, and people can find the files on the blog post, right?
Yes, exactly. Yeah, just search on the blog post for the matrix sniffer thing or whatever. And these connectors might be very specific to the Rigol mixed signal oscilloscope that I have. I'm not sure.
Well, they can remix them. That's what's so great about. Okay.
Yeah, exactly. You get the Eagle files, and you can make whatever variant you need. So
all right.
that's
my
showing.
Thank you.
All right, thank you so much, Phil B.
We'll see you next week, perhaps.
Yep.
Okay.
Yeah.
Next up.
All right.
Liz.
Next up, Liz. Hello, Liz. How are you?
Hi. Good. How are you?
Good.
I'm just going to share my screen really quick. Okay. So I've been blinking LED here. It's a really simple circuit, just 2 transistors, 2 caps, and 4 resistors. And the reason why is when you guys showed the copper sheets, I think it was 3 weeks ago in new products. I had just gotten a cricut recently, and I immediately was like, I wonder if you could cut a circuit out with that and like make a paper circuit. So I first did this one, which the traces were a little too small, but it was like proof of concept, so that was good. And then today I got some thicker traces going, and I think this will work well. And right now I've just kind of put the LED in so that it'll be getting power and ground. And it's working. So I'm going to try to get the components in and hopefully have next week to show you guys working on the paper.
That's cool. So you cut it out on the Cricut cutter, and then
Yeah.
you peel it off and peel it on. You have like a transfer method.
Yeah, so what I did was I actually, on the paper, I also cut out the holes from the circuit and also used a Sharpie to draw the traces. So then I can place the copper in there, kind of like almost like putting in a decal. So that worked pretty well. And using Eagle, I exported a DXF, brought it into Illustrator, turned it into an SVG, and then brought that into Cricut. And then with a little cleanup, it works pretty well. So.
Okay.
Wow, that's super cool. One project that got put on pause, but I hope to resume one day, is we got copper sheets with sticky back, and I wanted to have a Cricut cut them out and then put them carefully on a plane of glass and then use that. So if you get to that before I do, please do. But otherwise, otherwise, that is a project down the road that I thought that'd be pretty neat, because you can maybe have like a glass piano, suspend, glass panes.
Yes. Oh my gosh. Yes.
Yeah, you know what I'm talking about.
Yeah, that'd be awesome.
Okay. Cool. Yeah. Well, if you got that machine, go for it. If you got time. Okay.
All right. Thanks,
All right.
Larry.
Thank you so much.
The Copper Cricut Circuit. Try to say that.
Copper Cricut Club.
Copper Cricut Circuit
Yeah.
Club. Okay.
Okay. Next up, Mohib, how's it going?
Hey.
Good. How's it going? Can you hear me?
Welcome.
Yeah. So I got a couple of things. I'm gonna go ahead and plug this in so it boots up. So I just published a new post on making a talking quote display to get speech synthesis on a circuit Adafruit PyPortal using CircuitPython. So what it's doing right now is it's going to make a request to a serverless backend I've set up that uses Amazon Poly to generate the audio file as an MP3 file, store it in S3, and then the PyPortal downloads it and then plays it. So
I am an Adafruit PyPortal running CircuitPython speaking to you using AWS serverless.
I don't know if you guys heard that or not.
Yeah, that was
neat.
great.
So it uses Poly to generate an MP3, and then you just use the built-in MP3 playback to play it after you cache it on the. You don't stream the MP3. You actually store it and then play it.
Yeah, so I went down a bit of a rabbit hole trying to figure out. It also plays quotes. Yeah, so right now I have it picking quotes that relate to equality.
Oh, great.
And so, so I tried to do the whole streaming thing and I couldn't figure out, because doing audio and network stuff on like secure HTTP stuff is a whole rabbit hole that I went down for a while. And at one point, I had made this so that it worked off of AWS IoT, so it was more asynchronous, where you would publish a message and then once it was synthesized, it would update. But then I couldn't also download the file because I guess I couldn't have a MQTT socket open and do a web request. So, but in the process, I did find there was a bug there was a AWS IoT, the new asserts missing from the Nina firmware. So thank you for letting that pull request get merged. So AWS IoT works again on the PyPortal. I also got another project. I swear it's not a bomb. I've gotten in trouble for cardboard electronics projects in the past. So this is also at the PyPortal. I haven't added the cloud part yet, but it's basically like a lockbox where you can text. You would type in a phone number and then it would text like a one-time password. So I'm just gonna unlock this real quick.
Okay.
So I just hit unlock on it. So it's got a I literally wired this together.
Yeah.
Yeah, so and then a bunch of masking tape. And then you would type in the number and then it would lock, and then that person would have the code to then unlock it.
That's cool.
Yeah, and let's share my screen real quick. Technical difficulties.
I see some like static.
Yeah, this is like
this is like Tron. I'm getting beamed into the Matrix now.
Yeah, it's here. I'm gonna just.
I'm committed to this now.
Yeah, 1 second.
While you're going, where could folks find out about these projects?
Yeah, so I have my screen shared. Can we pull that? Yeah. Awesome. So I have the blog post that runs through it all on the Amazon Compute blog or the AWS Compute blog. Cool. So that walks through all the setup, how the backend works. It's one-click deploy, so there's no like having to go in and manually figure things out. I've made like a nice application template for it, and then you just drop in the CircuitPython code and fill in some of the parameters or the resource outputs. And it's also all on GitHub. So
this is also a neat side effect. I didn't think of this application when we added MP3 playback, but yeah, a lot of audio services are going to give you an MP3 output, whether it's a voicemail or a message or a text to speech.
Oh yeah, and I tried initially to do it as WAV files, but they tend to get larger in MP3. So this saved me. I didn't know. I found it. I was so happy when I found it because I had tried to do all this in Arduino and figuring that all out, and then I found somebody added MP3. It's just like in there in the docs, and it works.
It just works. Okay, patent ended, so we've added it. Ogvorbis next. Yep. Somebody wants it.
I wanted to drop a mention of. So I have a YouTube channel, hack.build. If you go to that link, hack.build, it'll take you to the channel. Was it last week we did a Black and STEM live chat? So I had a couple of old colleagues from a previous life come in and chat along with Odd J, if you know him, does cool robot stuff. And we talked about kind of the issues around being a person of color in the tech industry, what are common things, and what people can do to be better allies and comrades, and what employers can do to help make it a more psychologically safe environment. So please, if anybody has some time, go watch that video.
Subscribe.
Yeah, not only that, can you drop me a email PT@Adafruit, and we have an entire section of our site devoted to diversity, inclusive activities, and more. I'll drop that in there as well so folks can check it out.
Thank you. Absolutely. Awesome.
Okay. When we get back to stickers, we'll send you a bunch of stickers.
Okay, cool.
That was super worthy. Okay. Next up, we're going to go to Tim.
Hey, Tim.
And then Tim's screen here. And then we got two more people after. I'll just give you Jeremy.
Unmuted, the bane of all video chats ever, remembering when you're muted. So you might hear a little music in the background. That's actually coming from this radio here. So this is an old vacuum tube radio by Zenith that I inherited. It has 7 tubes in it. And just a little tip, right? Any old electronics that contain electrolytic capacitors, usually they have gone bad by this point. And in some of these old electronics, they actually stuffed 3 values of capacitor into a single can. That's what this large cylinder at the sort of center of the picture is. And that's what the underside of the chassis looks like, with nice point-to-point wiring. And then here I am just disconnecting the bad electrolytics, which are typically used for like power line filtering and anti-ripple. So the values, they just need to be close, but a lot of the older capacitors use literally paper as the dielectric, and that doesn't hold up after a number of decades. So sorry, I got these from Mauser, not from DigiKey.
That's okay.
So
it's all part of the family.
Yep. and then that's what the radio looks like back together. So it's mostly working, but it actually plays music now. Has maybe a couple of other smaller issues, but just something for any older electronics out there. Electrolytic filtering capacitors, probably good matter, of course, to just go ahead and spend a couple bucks and replace them. And that's what I got.
Yeah.
All right.
We had what's his name here with the scan to a microscope. It was almost all capacitors. It's just they just die.
My joke when Lady 8 is working on a project and it's not working out or something will be like, you should add a capacitor. And like sometimes I'm right. Like 1 out of 10 times it seems like I know what I'm talking about.
Like,
wow. So you should really add a
Such a
capacitor.
little genius.
Yeah, you'd think minus 20 plus 80% would be pretty wide for most electrolytics, but sometimes they can be way outside of that and not working at all.
Thank you, Tim. This looks like a beautiful project. Nice work restoring it. Come by with more projects.
All right. Thank you.
Thank you so much, Tim. All right. Next up, we're going to go to created by Jeremy. And then after that, we're going to go to Matt.
Hey.
Jeremy. Go ahead.
Oh, Jeremy's got a workbench here.
This is great.
I have it's the man cave. If I can have it in the room, I can own it.
Okay.
That's the Weiss rule.
Okay.
So this is not showing very well. This is a touchscreen controlled power center for Alexa controlled. It's cellular though, and on the back you've got power outlets and USB outlets. And the cool thing is you can control it with Alexa over a cellular connection. It uses an AT&T, their new NT IoT Sims, which it's a 64K connection. It's $30 a year.
It's amazing. They're like they found a good alternative to 2G.
And and so one of the problems I had was though that the latency is so high on it that it changed some of the code so that it would store variable and then run through when you did the loop, run through the code. It's written in particle, so it's kind of Arduino-ish, right? So particle boron.
Yeah.
And but it's there's also a lock on it. So when we have anything that's Alexa controlled, this is supposed to control network gear. See if I can get it. That's just horrible.
Yeah, I see it. And then, so you did it. Tell Particle about it because they always want to see cool projects. If you haven't shown the dev team there.
Yeah, no, I wrote a library and a bridge for Alexa.
Great.
So you can do like Alexa in like 6 lines of code.
Yeah.
It's first attempt at a cellular device. Really kind of fun little project. So.
All right. Well, excellent work.
Well, the only thing that you're missing from your room there, and you have plenty of room for, although there is a lot of stuff in there, is a sticker. As we get back to being able to send out stickers more, just drop me a PT Datafruit, and we'll send you an SC Gnome Show and Tell sticker.
Yeah.
That would be awesome.
Yeah, it's funny.
All
It's
right.
like at first you're like, is that a real background or is that Photoshop? There's so many times.
I get that all the time. Actually, it's like, is that a Zoom background? I'm like, no. See, it's
these are real.
that's real.
That's the thing now. You have to shake your camera to prove that your background's real.
I know, right?
Thank you,
Thank you so much, Jeremy.
Come by again as you do more projects. We'd love to see them.
All right.
Next
Matt,
up.
play us out.
Hey,
How's it
Matt.
going, Matt?
Hey everyone,
outside?
this is super cool.
Hey.
So I've been working on this Heliostat project since the beginning of the coronavirus, I guess. And basically a Heliostat is like a mirror system that tracks the sun and then bounces light at a particular target throughout the day. And so this is the sensor rig, and the sun basically just set, and so it doesn't have direct sunlight at the moment. But this is the sensor rig. There's 4 light sensors. And then here's the Arduino and the electronics back there. And then there's a central pivot and servo back there, and then another servo up top there. And so, yeah, basically the sensor will track the sun depending on a bunch of conditions. And then you can't really see it anymore, but up at the very top of the garage, if you can kind of see that little piece of light, that's where the sun is being directed right now. And I have like some pots so I can determine where the position is to the target, and just been working on a lot of stuff to try to kind of smooth it out, dealing with 270 servos and like millisecond control and all that kind of stuff to get the resolution that I need. And so it's been a super project, and just working it so that I can daylight my interior spaces without having to turn on the lights.
Oh, that's so interesting project. Yeah, what a
It's a
cool
good
idea.
idea.
I was thinking like, is this like a solar panel or like a solar oven? But yeah, you just want to like get more sunlight into your workspace. It sounds like a great project. And I love the detail of the wooden build there. It's or plastic. I can't quite tell the material.
That's cool.
You can tell it's so well designed. You spend a lot of time and love on this project.
Yeah, it's been super fun. So thank you all for like providing the opportunity for like all this, these resources and, a place to share this stuff. It's super cool.
Yeah,
that's a nice robot friend that brings you light. We always try to come up with robot friend ideas because we don't really do like battle bots and stuff like that. That's a robot friend. It reminds me of the little helpful robots in Interstellar that we're always trying to help you out. Anyways, thank you so much, Matt. As we get back to shipping stickers, because we're shipping all of the orders and more, just drop me a note at some point in the future, and we'll send you out a sticker. You can put an Asking Show and Tell sticker for your light robot.
All right,
cool. Thank you so much.
All right, thank you so much. That's our show and tell tonight.
That's right. We have another show coming up.
We do at 8 p.m. It's Ask an Engineer.
Don't go anywhere. Go get us the coffee, come back.
Thank you so much, everyone, for making this the best hour of our week every single week. And just to go along with the last theme, there are dark times, but the light can come.
That's right.
And sometimes the robots help bring in the light. And sometimes we build the robots that help bring in the light. And that code, that beautiful, those words that turn into math, that turn into actions, those are the things that we share. Those are the things that we do together. And these projects that you see are a good example of people making physical things, people taking code, being able to move servos, being able to make light come out of things, rainbows shooting out of LCD panels. If you're looking around for stuff to do, look at the playlist on YouTube of old show and tells. You'll just see people do projects week after week. You'll see some people, because we've been doing this for 10 years, going from a 10-year-old to a 20-year-old. That's always a trip. When you see someone, they go from kid to adult, and you see their projects over time. So thank you so much, everyone, for being here. We'll be here next week, 7 p.m. Eastern time, every single Wednesday. This is Show and Tell. Ask an Engineer starts in about 10 minutes.
Thank you, everybody.
All right, everybody.
See you soon.